Welcome to the Microscopists, a bite-sized bio podcast, hosted by Peter O'Toole, sponsored by Zeiss Microscopy. Today on the Microscopists.
Today on the Microscopists, I'm chatting to Chris Lintott of the University of Oxford and co-founder of the Zooniverse and co-host of The Sky at Night. And we talk about the public engagement in science.
So I think there are sciences that are naturally going to be more in the public eye. And I think those fields have a responsibility to invest in excellent engagement and outreach.
How alien invasion can wreak havoc on your vintage.
One of the rules, I think in Bordeaux, but it's actually Burgundy, is that if an alien spacecraft lands in your vineyard, then you cannot, for the next 3 years, call yourself proper Burgundy wine.
And why everyone should try real tennis.
It's a brilliantly ridiculous game. You get a point if you hit the unicorn, for example.
And why it's not helpful to plan too far ahead.
In my experience, at least, the path is much more random. And you're going to be much more buffeted by random events, jobs that open up, data that becomes available, things you find. And so it's almost not worth worrying about too many steps ahead.
All in this episode of The Microscopists. Hi, and welcome to this episode of The Microscopists. And today I'm really fortunate to be joined by Chris Lintott, who is an Oxford astrophysicist. He's, importantly for today, actually, the creator of the Zooniverse. And maybe I should look at my background first and done a background check, but also presenter of Sky at Night. So at this point, I'm really, really intimidated, although Chris, I just found that out. Chris, how are you today?
Well, I'm sorry I'm intimidating, but otherwise I'm fine. It's lovely to be here, and I'm looking forward to having a chat.
Yeah, no, I know you through others, and no, I'm not really that intimidated. I know you
good,
and everything else. So I know when I invited you to talk on the Microscopist, your question was, well, I'm not a microscopist, but I think you have had profound impacts on the life science and the microscopy world. And so actually, I thought it'd be great to get to know you, your initiatives, and really hopefully inspire other people to work with you and to help some of the projects that you're involved in. But do you know what? Let's start with the astrophysicist part. What inspired you to start with to become an astronomer rather than a life scientist?
Well, unusually, I'm an astronomer who grew up looking at the stars. So most of my colleagues are sort of escaped physicists or mathematicians who find the problems interesting. I grew up as a kid in Devon, looking up at the night sky and asking questions about what I was seeing. And the thing that inspired me then was the idea that we could tie observations, like the fact that some of the stars were different colors, to the physics, to the understanding of the cosmos. So that was the idea that inspired me. And really, I've been lucky enough to keep asking those questions and trying to understand the universe. The other great secret, of course, as this is primarily talking to people who are interested in life sciences, is that physics is much easier. And astronomy is much easier than trying to understand something as complex as a cell, let alone an organism. So I'm quite lazy, and I like nice, simple problems. And if you're trying to describe the universe as a whole, you have to do it at a level that is nice and simple. So maybe I've just started with the easy stuff, and we'll work up from there.
I think if you could explain the Big Bang and where those two particles came from to start with, I see that is mind-blowingly difficult and complex. So I think
we don't understand that bit, so that's fine. I can do everything after that. So I often tell people, because I'm an observational astronomer, so I get my hands on data. I like playing with telescopes. I like thinking of new ways to look at the universe. So my domain starts probably a few minutes, and more likely about 400,000 years after the Big Bang. The theorists and their chalkboards can have the first few minutes.
Yeah. So you're focused on the long game. They're focused on this very, very, very momentary event, I guess.
Right.
Chris, so you're into astrophysicist aspect to it and star formations. if you don't mind, how old were you when you became professor at Oxford?
Let's see, I was 33, which is pretty early, but I got lucky and things fell into place a bit, and it's a great privilege. It's wonderful to have got there. But for me, the important bit was just to keep getting to do what I'm doing. I always assumed that at some point I'd run out of road and stop being an astronomer, and I'd have to go and, I don't know, find something else to do. So for me, like, the great privilege, never mind the title, is to be here and to be able to work on slightly crazier projects, unusual things with great people, and yeah, it's an amazing thing.
So you don't. So have you ever found it? I don't know. Have people ever looked at you with envy, or just take it at 33, such a young age to be a professor? Mind-blowingly young. Has that been a good thing or a bad thing or a mixed bag?
I'm not sure that being a professor made much difference. I got my own pigeonhole, so that was nice. And I think my parents finally understood what it was that I did, because they recognised the title. But apart from that, no, I think, in academia, I think it really is those of us lucky enough to have a permanent or semi-permanent job versus everyone else. And that was a big moment a few years earlier. I haven't really thought about the age piece. It's not something that I keep track of, really. So it didn't feel young to me, but then I'm not sure how. I'm not really answering your question, because it's never really occurred to me. So
I've just given you a complex.
yeah, maybe I'll worry about it. But in envy, I'm not sure. I mean, I think being at Oxford is weird, because I love this place. It's got great things going for it. But in the world, particularly in the US, you say Oxford and it has all sorts of connotations. And obviously in this country, you say Oxford and there's a certain sort of Brideshead Revisited type stereotype of people punting down the Thames and opening champagne bottles. And we only do that 3 or 4 times a week. So I think being at Oxford adds this extra dimension to it that's a bit strange. And it's interesting, being an astrophysicist is a thing as well. So the joke is that, except that it's true, is that if you're talking, let's say you're talking to somebody on a plane or something, you want to have a conversation with them, you say you're an astronomer. Everyone has questions for astronomers, whether that's, have you seen aliens? Do you know Brian Cox? These big fundamental questions. Or if you don't want to talk to the person sitting next to you, you say you're a physicist, and then that's it. It's done. And so astrophysics is the thing. But I was an astrochemist originally. So my PhD was on the chemistry of star formation. So it comes back to trying to understand the universe through observing it. You need as much information as possible. And so if you think about chemistry as well as physics, you think about composition of the molecules that are forming, we could get much more information about the processes of star formation. So I call myself an astronomer first and foremost, because that's about looking at the sky. I do astrophysics and there's a bit of astrochemistry. These days there are astrobiologists knocking around, and I know at least one person who thinks they're an astrosociologist, which is trying to explain the likely structures of alien civilizations. So I guess we've reached the life sciences after all.
Actually, surprisingly, astrochemists. So actually, probably worth listening to Scott Fraser's The Microscopist with Scott Fraser. He was a physicist, stroke chemist, stroke biochemist, so he's kind of dipped into all sorts. But one of the big things in light microscopy some 20 years or so ago was unmixing colors, fluorescent colors, to enable us to look at more colors that were coming out of our fluorescent images. And actually, that was inspired through the deconvolution, the algorithms coming out of astronomy and astrophysics that are mixing the colors you are seeing down to the components, and using that single component analysis, deconstructing them into the different colors.
Yeah, which is something we're used to doing. I think astronomy is an interesting field, and it has these links to other fields, because I think we were very early to adopt digital detectors. So the sky surveys in sort of the early 90s had switched to electronic cameras from film, and so that I think we had a lot of exposure to those techniques early on. But also because astronomy data is basically useless. It has no commercial value whatsoever. And so we tend to be a field that is very open with our data and our algorithms and our processes. So I think that leads people to collaborate with all sorts of people. That I could look around the country. My colleague Brooke Simmons, who we might talk about her work in a bit, but she does disaster relief projects on the side, analysing satellite images to help first responders. Sarah Bridle in Manchester, who I did work experience with back in the day, now leads a big program on food security using the skills that she acquired as a cosmologist, as an astrophysicist. So I think there's something about the fact that we're used to working collaboratively with large data sets and often imaging data that means that we're a field that tends to pass on techniques to other places. Plus, I think as a group, as will be obvious from this interview, astronomers, I think we're pretty distractible. And so we can be seduced by new problems in other fields. And I think that happens to lots of us.
Well, I think, so I mentioned the spectral and mixing part, Scott, but actually you then went back to the digital cameras. And actually, it was back in the 90s I started using my first CCD camera from Wright Instruments, which I think was Oxford-based at the time. And with liquid nitrogen chilled CCD, tiny
Right.
512 pixel, I think it was. Yet again, I was conscious that that came from the astronomy side and into life sciences. So actually, it's a really good advert for physics and the funding of physics and astronomy. Some people may argue that what's the point of understanding the stars when there's more fundamental things back on Earth to solve? And yet it's those CCD cameras, it's the algorithms, the things you just highlighted, it's the impacts that they then benefit. So it's far greater.
Yeah, I think that's right. I think, that there's that general argument for blue skies research is a good one. I think we have a very bad track record of predicting what will be useful in 30, 40 years. And astronomy in various ways lays claim to Wi-Fi, uses algorithms that were developed by Australian radio astronomers, and as you say, CCDs and all the rest of it. But I think it's also I think we can be actually, and we share this with some of the imaging life sciences as well. I think there are sciences that can be a sort of gateway drug for the public understanding of science as well, or for education. So one reason to have astronomers around is what I mentioned a minute ago, which is that people have questions for us, that people can be drawn into talking about science much more easily in astronomy than, I don't know, if you're condensed matter physicist. Some of my best friends are condensed matter physicists. There's nothing wrong with being a condensed matter physicist, but it is harder to get a conversation going in the pub about your latest research than when we found some new planets or taken a beautiful image of colliding galaxies. So I think there are sciences that are naturally going to be more in the public eye, and I think those fields have a responsibility to invest in excellent engagement and outreach so that people could be drawn into science as a career or as a hobby or as part of their lives. And so I think there's also that pitch to it as well.
So I guess that ties nicely onto the importance of communication of science. And as you said, as a child, you look up, you can see the night sky, you can be curious to know what's going on, what creates it, how things are moving. It's completely different. And communication is really important. And so I say I should have done my background reading. So you are now a co-presenter of Sky at Night, which for those who are not in the UK is the astronomy program that you tune into. And I think almost all children, certainly at my age, would have watched Sky at Night through the ages. And it's serious and not serious, but there is quite heavy content in there at times. But it was always engaging.
Yeah, I think that's what we're aiming for. So Sky, it has various distinctions, but the program started in 1957, which is before the space age. It started a few months before Sputnik went up, the first satellite. And it's every month, which is odd. It used to be every lunar month, which was because it was felt that people who are interested in astronomy in the 50s would want to look at the moon. So if you put on a program at the new moon, when the moon is invisible in the sky, people would come in and watch. And it turns out we have a broad audience for that. The BBC lost track of the lunar months sometime in the 90s, and it shifted to calendar months, and now we take a little break as well. But I think the other distinguishing feature about the Sky at Night is that it's made more or less on a shoestring budget, which means we kind of get left alone to do what we like. And so we get to produce a very unusual program, I think. what we try and do is make sure that everyone learns something from every episode, which means that if we're making, I don't know, we made an episode 2 months ago about a European Space Agency satellite called Gaia, which is mapping the nearest billion stars to us. And I think we started the program by saying that the Milky Way is a galaxy, that it contains 100 billion stars, and some of the people watching will have learned that and be blown away by the idea that there are 100 billion stars in the galaxy. Well, plus or minus a few hundred billion. There are hundreds of billions of stars in the galaxy. We're not really sure. We haven't finished counting. But we also talked about the fact that the exciting result, if you're deep in the field, is that some of the stars in the galaxy trace a merger between our galaxy and a previous, a smaller system that happened 10 billion years ago, that was the most significant event in the history of our galaxy that no one had suspected had happened. So to try and do both of those things in a program is quite odd, but I think it works, and we're managing to keep going with a very loyal audience of people who tune in to listen to whatever we have to say.
What are the viewing figures like now for it?
I'm not sure I'm allowed to say, because I'm not really a proper BBC, but hundreds of thousands of people.
Yeah.
What I do know is that I was once told we were the cheapest program per viewer on British television, which I think you could draw one of two conclusions from.
And you've done well, because you obviously picked up the mantle. Your co-host picked up the mantle from Patrick Moore, I think it was, wasn't it?
That's right, who presented it from 1957 till 2012. Although I overlapped with him, we worked together for the last 10 or so of those years.
And how was that? I'd love to know what Patrick, working with him.
Yeah, well, he was exactly as he was off screen as he was on screen. So I guess if you have an international Patrick, it was the embodiment of sort of what you draw as an English eccentric, a man of many obsessions and passions and strong opinions, but who loved conversation and more than anything else. So his favorite thing would be to have a room full of people, preferably people who are interested in astronomy, and to sit up late at night talking. So for a few of the years towards the end of his time on the program, we made the program at his house, and it was like going to summer camp for astronomers. And we'd had, world-renowned scientists, people who'd built missions that had gone to Mars, would come down, stay, and the producer would spend half of her time trying to get people to go to bed early instead of sitting up and talking, because we had to film the next day. It was just great fun, and he was an incredibly, if he liked you, he was an incredibly generous man. So when he became less able to travel, this is how I got into the program, was that I was a researcher. I was supposed to be behind the scenes, helping the production team make sense of the complex stories that we were telling. But but Patrick immediately said, well, we should go to this conference, we should cover it. I can't go, Chris could do it. And so I started doing little bits and pieces like that and got thrown in front of the camera, which meant that I got to be bad on television. And no one gets to be bad on television anymore. You have to be good the first time, and you're either a star or you're nothing. Whereas I had this apprenticeship, essentially, where gradually I sort of worked out, I think, how to interview somebody, how to make sure I'd actually bothered to iron my shirt before going on. How to. No, you're good. There's just some archive footage that I saw recently that's not great. Historic moments like the European Space Agency's Huygens landing on Titan. That footage will be watched in 100 years' time, and all they'll wonder is why on earth I didn't know how to iron the shirt. But the point is, I learned presenting as a craft, and I think people ask me how to get a career in science television, and the truth is I don't know. I was really lucky and stumbled into it via Patrick, who had the generosity to say that the program and the stories that we wanted to tell were the most important thing.
Now, you mentioned late nights, so I'm just going to move the conversation on a bit. So what are your favorite drinks if you're having a late night?
It depends on mood. I'm often found with a glass of red wine, to be honest. I think red wine, but
so I've got a background. For those who are listening, what is this background of, Chris?
So this is the label of one of my favorite wines. So this is a wine called Le Cigar Volant from California. And I think this is a really good example of astronomy being in the culture in a way that we talked about. So this is a Californian wine that's made in the style of French wine. So there's a bunch of Californians who 30 years ago started to make wine like you make in the south of France. And Le Cigar Volant is obviously a flying saucer, and you can see there's a saucer there beaming down onto the vineyard. And the reason it's there is that French wine has a long, strict list of rules that you have to, if you want to make wine in a particular place in France, you have to really follow the rules. And they tell you what grapes you can use, but also maybe when to harvest, how you can treat the grapes afterwards, and so on. One of the rules, I think in Bordeaux, but it's actually Burgundy, is that if an alien spacecraft lands in your vineyard, then you cannot, for the next 3 years, call yourself proper Burgundy wine. You have to declassify. You can only sell as Vin. So Le Cigar Volant claimed to be the only place in the world that actually guarantees this. So they pay an astronomer in wine to certify that no aliens have intervened with their website. Now, that's not me, but if they're listening, I will happily take that job on. But I also think it's a really good example of how, astronomy sort of infuses people's lives in all sorts of strange places. So I like the fact that my subject crops up all over the place, and I do like a decent glass of red wine.
I've never had a glass of it. Is it good?
It's excellent. Yeah, actually really good value as well. I highly recommend it. But you need to open the bottle about an hour before and just let it decant first.
Yeah, actually, our local Field and Fawcett, they sell it, but they haven't got it in stock at the moment. I did look when you.
Nice try. Yeah, it's a bit. I don't know if we were doing this on a Friday morning. It's a bit early for a bottle of wine. But yeah, I did notice when we started doing in the pandemic, when we started doing things from home, I filmed from this study for Sky at Night, filming myself on a little camera, which is pretty stressful. But you suddenly became hyper aware of what's behind you, and I've got a couple of wine boxes that are nice. They're sort of wooden crates from various things that they actually got books in now. But people started noticing them and commenting that I was clearly, again, Oxford professor, nice wine. There's a certain image, and then people were putting out, I've got trashy sci-fi underneath, and so it was quite fun watching people try to put these different bits together and try and come up with a person. So the Oxford professor wine bit works, but then cricket and sci-fi and various other bits knocking around confused people.
See, my background is literally as the office was, and the picture wall is actually because I'm useless at putting up pictures. So actually, for my wife's birthday, I think it was, I put up a big board that we can just easily put pictures on and have lots of pictures in one place and leave the rest of it a little less cluttered.
Nice, very good.
And just moved into
No, I just have books everywhere, which is a problem that is increasing during lockdown. So yeah, at some point more shelves are needed, but we're doing okay.
Le Cigar Volant is also, bit of background, a restaurant in Fraser.
Is it?
It is.
I didn't know that.
There you go.
I have a friend who's a big Fraser fan who will be very disappointed that I didn't know that. But well, there you go. This idea would probably link to the wine. These ideas spread out and escape.
Yeah, I think they'll have known that backstory and just love the backstory to it. It just adds the depth and complexity to it as well. So you mentioned the sci-fi books. So any particular sci-fi favorites?
I have all sorts of things that I read. I've been reading a lot of it's really interesting and go back and read sci-fi from the 50s and 60s and to sort of look at what at the time was trying to imagine technologies. But I think the best book I know, which everyone should read, is a book called Star Maker by an author called Olaf Stapledon, who was an Oxford philosopher in the 1930s. And he wrote, they're very strange books. They're sort of about a cosmos that's shaped by thought, by people's imaginations, really. And there's a sort of grandeur of imagination to it that he makes impossible. So it's not really that they're not, his books are not about starships and space operas and battles and Klingons and all the rest of it. They're about ideas and thinking about the cosmos. So Star Maker is just brilliant, and everyone should read it. My favorite of his is a book called Last and First Men, which is a history of the next, I think, 6 billion years. And he has this idea that intelligence evolves and inevitably destroys itself. And then there's a long period before intelligence rises and fades again. And each time the story is different. So he goes through. So for example, in one possible scenario, the intelligent beings create supercomputers to think for them, and then the computers take over before the computers decide that actually they need creativity, and so they switch themselves off and wait for the next evolution. In another chapter, people learn to fly and develop wings, and then flying is so much fun they decide to do nothing else and thus go extinct, and so on. So last and first is just, but again, it's about, imagine sitting down to write a book about the next 6 billion years. There's a sort of mind-stretching intelligence to that I think is really good. And everyone, I recommend Last First Men, but the first 100 pages is a Marxist analysis of mid-20th century politics, because we end up killing ourselves in a nuclear war. So I'd skip the first 100 pages unless you're particularly into 1930s Marxism, and then read the rest.
So politics, evolution, sociology,
flying,
all put into one. It's where we started today, isn't it? Everything's in there. It's quite something. You mentioned Klingons and everything else. Star Wars or Star Trek? What's your favorite?
Trek, definitely. I grew up watching Star Trek, both the Next Generation and the original series. So, although I have to say, I went back and rewatched a lot of the Next Generation, and I'm not sure it stood up very well. Apart from the fact that I think Patrick Stewart is an amazing actor, and I'd watch him in anything. But definitely Trek, and the more astrophysical, the worse, really. So I like it when they don't try and explain the science. So there's a great Star Trek anecdote, which is somebody wrote and asked Gene Roddenberry, who founded it, exactly how the Heisenberg compensators in the teleporters were. And that's, so if you're going to teleport, you have a problem with quantum physics, because you need to know the precise position of every atom if you're going to transport somebody and have them turn up the same as they started. So the show knew this, invented things called the Heisenberg compensator that fixed this problem. Somebody wrote to Gene Roddenberry and said, "How do they work?" And he said, "Very well." And I that's my kind of sci-fi. Don't give me a pseudo-scientific explanation that's wrong. Just tell me there's a magic box that does a thing, and then we can get on with the story.
That's a bit like the Big Bang then, isn't it? It happened. Don't worry about how that happened.
Oh, well, no, yeah, I think so. I'd love to know how the Big Bang happened. I just don't know how to, I put that in the too difficult box right now. But I guess, if we're talking microscopy amongst other things, like, you must get there's all sorts of movies and sci-fi that depend on the view of the very small, Jurassic Park or whatever. You must get distracted when that's not right. Right? Do you get implausible uses of microscopes in?
I think the biggest one is forensic things on different programs and stuff. And I think almost every microscopist spare bug will be when they look down a light microscope and they show an electron microscope image.
Oh, yeah, I hadn't even occurred to me.
It's completely unfeasible. It's like, oh, come on.
Right. Because I thought you were going to say there's always the thing in those dramas where they say enhance and the picture gets better. Instead of applying for a grant for more kit, waiting 6 years months, getting it installed.
Yeah, like software is really that good yet. Although software should be able to help us get there and enhance it as well as it does if you've got it. Still don't understand why we can't get better CCTV of actual criminals. Just merge the images, just deconfigure. Good grief.
Right.
If we can reconstruct the structure of proteins, surely we can reconstruct someone's face off a load of blurry images.
I don't know, that you probably can now. This is the that's a serious machine learning challenge, and I suspect people are disturbingly good at face recognition now. But it's about where we deploy that. But now we're back into politics again. I think maybe we should retreat to sci-fi.
You also mentioned machine learning, and that I think brings us nicely onto citizen science and Zooniverse, which is, your career is just unbelievably impactful, if that's a word, from the start. And this is really, how I got to know about you, and just how I found you inspirational and what you did and how you were helping Martin Jones and Lucy Collinson down at Crick. And I think Lucy even mentions Etch as part of Zooniverse. So actually, if I go from the Zooniverse, I can find the Etch.
There you go.
Oh gosh, I've got no. I'm getting older. Lack of hair. This is so. I collaborate quite closely with Lucy, and a fundamental problem in life sciences is we can get great images, Making sense of them is really difficult. Getting software to draw lines around objects that we can easily see is really complex, because there's other lines that obviously don't relate to it, but software thinks it does. And it's citizen science, it's Zooniverse specifically that is enabling them to take giant strides in this. So I don't know how well you know Etch-a-Cell.
No, pretty well. So the story of Zooniverse in a nutshell is that we had too many galaxies, or at least we had images of 1 million galaxies that we needed to sort out. And this was 2007, something like that. I just arrived as a postdoc in Oxford, and we'd shown that it mattered to have people look at them. That at the time, at least for that task, people outperformed machine learning, and so, taking inspiration from a few other projects that had run elsewhere, we put those images online and asked people to help, thinking it would be a nice small project. My idea was that I go and talk to local astronomical societies, clubs of amateur astronomers around the country. I thought, okay, talk to 50 people a month. If they go and do 50 galaxies each, we can sort of have this nice side project. The web doesn't work like that. You either succeed slowly or beyond your wildest dreams. And we were getting 70,000 classifications an hour, 24 hours after launching.
So 70,000.
70,000 classifications an hour were coming in a day after we launched. And that was the peak, but we kept going, and we'd quickly run through the images. And the data was really good because we had lots of people look at each image. So part of the power of this approach is not only that human pattern recognition is very good, so these are naturally tasks that anyone can do, but that because we have lots of people do each task, you get a sense of accuracy as well. Almost immediately after Galaxy Zoo, we started to get hear from other researchers who wanted to know if our crowd of volunteers could do other tasks. And I've already mentioned that astronomers are pretty distractible, and so for that reason, but also because we were sort of fascinated to try and understand why Galaxy Zoo had worked. And as an observational scientist, I thought, well, we need more data. So we started to build other projects to try and explore what works in this form of citizen science. So we built projects where we thought the images were really dull. We built projects where the task was harder. We built projects in completely different fields and started to build up what became the Zooniverse. And so after a while of sort of just responding to people who wanted to build projects with us, we started to think about systematically about where there was a need for people to look through images. And at that point, you hit your world pretty quickly. So we were lucky enough to get some funding. We hired Helen Spears, who's the real driving force behind Etch-a-Cell, who worked with me here in Oxford and is now with Lucy and Martin at the Crick Institute. And we built this project. And I don't know the technical details, but it's been fascinating to watch our volunteers engage with what's quite, as you say, quite a difficult task. I think we're not just saying it's a spiral galaxy or it's an elliptical galaxy. We're not just saying there are 17 penguins in this image, which is our most popular project, is counting penguins. But you'll say, okay, please draw around the cell nucleus or one of the other constituents of the cell. But I think the data itself is fascinating. It comes as, I'm not going to try and use terms, but where you're slicing through the cell and you're getting a three-dimensional picture of the nucleus out of the tracings that are provided by the Etch-a-Cell audience. I did biology in school. I thought that the cell nucleus was a nice round, probably spherical blob, right? Because that's what all the textbooks have, and it still blows my mind that that's not true. And that from Etch-a-Cell, we've got this nice three-dimensional model that shows structure within there. And I think it's grist to my biology is complicated mill, because it turns out not everything is a sphere. And it's been a really interesting project, partly because of that difficulty. We've had to get machines involved as well. So in the 14 years that we've been running Zooniverse, obviously machine learning driven by Google and Facebook and all the rest has improved beyond measure. And so one of the things I'm interested in now is how we best combine human and machine systems. So I begin to sound like a science fiction author at this point, but that sort of hybrid capacity where you can ask machines to do the things they're good at, but retain the human capacity for dealing with edge cases, complex problems, making discoveries, and so on. That combination works really, really well. And EtchCell is a place where we're on the cutting edge there, because having got people to draw around the cell nucleus on each of the image, we can then train a machine to produce a consensus map to take everyone's efforts and produce the final answer. And it's inspiring. Actually, it's coming full circle, and some of the astronomy projects I'm working on are now taking its inspiration from that EtchCell approach, which the team at the Crick are continuing to develop.
So just expanding further on that, future for machine learning is taking, so the critical thing here, it's not one person draws around one nucleus, someone else draws around another nucleus. Lots of people draw around the same nucleus. So it removes that human error. It removes the biases, mistakes. It gives you better confidence in there. And I think Lucy and Martin both said that they were gobsmacked at just how good amateurs, armchair scientists, were at drawing around these objects.
Yeah.
Such a skill to do it, but actually collectively, that there are some great people out there that are spending their time and doing it really, really well.
I think there's a couple of things. Just to say on that, because I think, sorry to interrupt, but I think it's really important that they're doing it really well because they care. And so one of the things we got wrong when we were setting up that first project was to think that people would be motivated by a pre-existing love of astronomy or a desire to discover a galaxy. And actually, every time we study or we run surveys of Zooniverse volunteers, people take part because they want to help, and they care that the data is being used for scientific purposes. And so taking those motivations, if you want to help and you know that somebody is going to use the data for something real, then you take a lot of time and care and attention. Then, of course, we combine people. So that does remove error. It gets rid of the very occasional bad actor. I think we must have had a school project, because one of my favorite EtchCell examples is somebody just wrote, "I hate this project," which is lovely. But so you get rid of those. You also get rid of mistakes, but you also get some sense of the inherent fuzziness of the data. So there could be 10 of us, we could all do the same task, and if we disagree slightly, that tells us something. Maybe the images are clear, or maybe there's some ambiguity there. So you actually get all of that information back as well.
I think you need that ground. So beyond that, getting so many data sets will hopefully help machine learning. So that gives you the ground truth data to if you just throw a computer at it to draw it, it can't. It needs to be informed first.
Right.
And you need lots and lots and lots and lots of data for it to learn from. And that's where citizen science and Zooniverse really play, and I hope will play, certainly microscopy as well. Cell tracking, even light microscopy and following cells is incredibly challenging. And you talk to a lot of computer scientists and think, oh, this will be quite trivial and easy. And you talk to some of the world's best computer scientists, and it's only once they see the data they realize, because cells are changing size, shape, that actually the characteristics when they go over the top of each other and come out the other side apart from each other, they look different. And the human eye can work out which one was which, but actually computers still really struggle. And I think, come on, everyone out there, if you're like Microscopists, live cell, try and find some energy to get this sorted.
Yeah, and we tried to make it easy. So we spent some time building projects for people, which was great fun. And then we found, probably 5 years ago now, maybe a little more, that we were building more or less the same kind of project again and again and again. So we built a tool. So if people out there have data that would benefit from this sort of crowdsourced citizen science approach, you can go to zooniverse.org/lab, and there is a tool there. It takes about an hour, and you can build a project using your own data, and then you submit it to us, we review it, and then put it out for our crowd. So research groups who have data but don't have any web expertise and don't want to develop any can build projects. It's rather like creating a blog or something, where you click some buttons and the project appears. I think you're right about the complexity of the data. That helps, and I think and you're right that modern machine learning, particularly deep learning, which is what dominates most of the headlines, depends on the size and quality of training sets. So one way to view a citizen science project like this is that it can produce large training sets that you can then train fairly standard machine learning with. So, for example, we have a project called Snapshot Serengeti, which has motion-sensitive cameras in the Serengeti National Park. I've now got a pretty good trained giraffe detector because we labeled 100,000 images of giraffes, and you can feed that into a network, and now we can find giraffes. Plus, they're quite easy; they're kind of distinctive. Ostriches are much harder, incidentally. So there's that one way thing. But I think the more interesting question is to say so in that picture, there's a sort of idea that at some point you take the training wheels off, the machine is fine, and then you just feed your data in, and your results come out the other end. And I think that's possible. We've had some projects that have achieved that, but for the kind of complex data where you really want to get every bit and byte of information out that you possibly can, I think that's a very ambitious goal. As you say, I think all machine learning projects are 80% easy and 20% impossible. And I think a lot of the projects I see from your world live in that sort of 20% impossible. So I think a more interesting question is
for now.
Sorry,
Yeah,
for now.
It's impossible for now. The future.
Yeah, but the thing is, data sets keep growing too. So there's this race. So you can say, okay, so I can label currently, let's say 90% of my data with machines, and I need people to look at the other 10%. So in 5 years' time, maybe I can label 95% of the data with machines. But the trouble is, your data set's trebled in size or quadrupled in size or whatever as well. So I think the thing to do is to accept that we're always going to need some sort of review and ask how we can make best use of that. So, for example, on the Galaxy Zoo project where we started, if you go to the site now, we have an advanced neural network built by my just graduated PhD student, Mike Walmsley, that's running in the background and analyzing the galaxies. And the site will show you not just the things that the machine is most confused by, but the things which the machine that Mike built predicts which galaxies will improve it further. So it will show you the galaxies where you labeling it will most improve the machine performance on the rest of the galaxies. And so you have this nice loop that will always involve a machine and always involve people that's running quite happily. I'm also very interested I'm sort of on tenterhooks. I'm waiting for a grant that I hope I'll get, that I've written, which is about the idea of serendipitous discovery. So I think another place where you need people is to be surprised. So it's very hard to teach a machine to be surprised in the right way. Machines can tell you what's unusual, but they can't tell you which of the unusual things are interesting.
I'm going to comment I just on that, and you said you can get 80%, 20%, and 95%, but actually what a machine can't do is still can't find out yet the interesting cells that we don't know are interesting, because they're outliers, things that we tend to we bias what we're looking for and concentrate and ignore quite a lot of information around it.
Right, I think that's right. And I think anomaly detection is a big field in machine learning. So outlier detection, because those are often the problematic things. But most anomalies in this talking at a very high level, but for most scientific data sets, most anomalies are boring. They're in astronomy, they're places where a satellite went in front of the field of view, or there's a bright star that's a glare. In microscopy, I'm guessing it's a misaligned cell, or the plate didn't work, or whatever. What we need, I think, from citizen scientists is to be able to identify which of the unusual things are interesting. And I think this will be a big move. I was delighted to work with. I worked with a team at the Diamond Light Source on a separate set of life science projects called Science Scribbler. And we've been talking about doing some stuff with cryo-electron microscopy, where you look at protein structures. And I was fascinated to learn that while people have managed to use templates to produce training data to find some of the most common proteins, in the cells that they're looking at, most proteins are rare most of the time. And so almost everything in that data set is an anomaly or is an outlier. And so this approach of let's just get 100,000 examples of everything and then train the machine isn't going to work there. And we're going to need to be much smarter about how we sort through that data. So I'm hoping to be able to get deep into that project in the near future.
So with respect, Richard Henderson talked about very similar things only recently. just to give people an idea, because it's all good and well, all these data sets, and it needs lots of data, it needs lots to be processed, and surely people are competing. But as we've heard, you've got people interested in astronomy and are passionate about it. There's people from Lucy's side that will be interested in cancer and helping cancer research, which is very much HSL's side of things. Do you know how many registered volunteers you currently have across and this is international, this is not just a UK thing, this is very international.
That's right, and we're actually trying to do more translations so that we can be more international. We've got a couple of million registered volunteers, and to give you an idea of the scale, during 2020 they contributed over 100 million annotations across all the projects.
Over 2 million people.
Yeah, exactly. And the thing is that they're motivated by helping. So yes, some science is more, as we discussed at the start, some science is more immediately accessible. It does help if your project has penguins in it. People do like penguins. But apart from that, what really seems to captivate people, what makes a successful project, is engagement by the scientists. So if you can explain why you want people to do something, and you're there to answer questions every so often when they are doing it, then we do see projects developing a loyal following from amongst the existing Zooniverse volunteer base. One of the reasons we created Zooniverse was that with Galaxy Zoo, as we had that initial success, we got a lot of press, and so people found the site through that buzz. We realized pretty quickly that launching our 20th project or our 200th project or whatever isn't going to generate the same buzz. And so we have an audience of citizen science fans who are excited by new projects. There are people on the platform who want to do every project, for example, which is quite fun. And I do think the sort of the worlds and the data that you're talking about are fascinating, and there's inherent variety. So I think the filter is, are there a set of images that people would get something out of flicking through? So we sometimes call this the poor sod problem. Like, we'd like to do this research, but some poor sod would have to look at 10 million images of cells or whatever. And then the second thing is, can you explain in a sentence what the task is? And if those two things are true, people should come and build a project and try it out.
Gosh, just think about the number of pathology sections that need someone to eyeball it and work out if it's if the patient's got cancer or infected or has an immune disease or something else. The ability for that to be with greater certainty than having to go through human eyeballs each time for grading and looking. And again, but then also noticing differences between patients, which could fundamentally change the way of science in the future. Yeah, I'm going to move quickly because we've talked. Get involved if anyone's listening, and if it's not yourself, your children, your parents, all sorts.
We have people of all. I know 5-year-olds have contributed to Zooniverse projects, and I know 90-year-olds have. So that's the range. And I think we try and design the projects. We don't always achieve this, but for the most part, from hitting the website to making a contribution should be less than 2 minutes, because I think the magic of these things as a participant is to know that you've done something real. It's a very different experience from coming to hear a talk or listening to a podcast or choosing to read a scientific article in the paper or whatever. I think we promise you that you will be able to help even if you've only got a few minutes to spare. I think that's why last year during the pandemic we saw an enormous spike in traffic, because for those people who were lucky enough to have more time to spend on things, I know that wasn't everyone's case, but that ability to be part of a community that's helping was really inspiring. And so certainly the messages we got from people showed how meaningful this sort of ability to help scientists was to them. And as a scientist, that reminds me why I'm doing any of this in the first place. It is a privilege to get to try and find out about the universe, and to do that in the company of 2 million people is really exciting.
It sounds like one of those board games, age 5 to 95. How competitive? We need to move on, but how competitive do people get? Do people think, have you got a group that are almost competing against each other for the most classifications or inputs? Or
yeah, it's interesting. we did early on have a leaderboard, and that worked for a few people, and we got rid of it. But we've done some research into this because people often suggest that we gamify the project. Where are your badges and alerts that tell you that you've got to keep up your streak of 10 days or whatever. When you put that sort of competition in, what's interesting is it's very effective. It turns out human beings are really incentivized by games and point scoring and competition. I think you kind of know that as my phone shouts at me to tell me that I haven't learned any German in the last 3 months, and I haven't been to play tennis in the last week or so, or whatever. So we're really incentivized by that gamification, but it changes how people think about the projects. They start worrying about whether they're winning instead of thinking about their participation. So we very deliberately try and discourage that sort of competition, because I want people to realize that science is a collective endeavor. We have a project called Planet Hunters, where people are literally discovering planets around other stars by looking at graphs for fun. And in Planet Hunters, the odds of finding anything are pretty low. So we have contributors who've looked at 50,000, 60,000, 70,000 of these graphs and not found a planet, but they're just as useful as the person who actually finds the thing, because they're the same bit of information. This isn't anything, stop looking at it, is just as useful as you should take a look at this. And so it is a collective goal. And so we try and set, this week, let's try and look at 1 million images, or this week, let's try and finish this project. And that seems to work quite well.
He's brilliant. Now, you mentioned there before rushing off to play tennis, so I've got would you like to describe this picture that I've just
yes, well, it's some very sweaty people, 5 of my closest friends and I, all holding rainbow colored misshapen tennis rackets. So this is at Hampton Court. So I play, I call it tennis, but it's real tennis, which is the old version. So it's played with a lopsided wooden racket.
There you go.
There's the home court. So this is my favorite place in the world that's behind you now. So this is the Oxford University tennis court in Merton Street, which dates back to the 16th century. It's the 3rd oldest court in the world. So people have been doing this sport with more or less the same rules and the same equipment in the same place for more than 400 years. And it's a brilliantly ridiculous game. You get a point if you hit the unicorn, for example. There various other bits of the court make bells ring if you hit them. It's very tactical. So the best way to describe it is it's like playing a cross between squash and chess in a pinball machine.
And you play it off the side roof as well. So there's
you have to serve. You serve up. There's a sloping roof. So it's difficult to describe, but it's supposed to be the shape of a medieval street. So on the left, you've got like a row of shops with sloping roofs. You roll the ball up onto the roof. There are about 40 different serves that people have invented, all called things like there's the caterpillar and the giraffe and the railroad and the hunting dog, which are all different types of serve you can do. And then there's a net which sags in the middle, and you can play forward and across the net. And then there are various other targets one can aim for. I think what I love about it, apart from the fact that it's a ridiculous sport, and I urge everyone to go and try it. It's great. It's physical, but it's also mentally difficult. And so when I'm on the tennis court, I can't think about anything else. So it's the one place I can be where I can really just concentrate and not think about work, not think about Zooniverse, not think about and anything else. It's just you have to be in the moment on the court, and it's a game that's about moving very fast and being very controlled. And the people in this picture, by the way, are the Oxford Unicorn team. So we went to Australia in 2019 to go and play 2020, start of 2020, to go and play a tournament in Melbourne, and flying across the world to play a ridiculous sport was great fun.
So you say you forget about work. None of these are work colleagues?
One of those. So the third one in is Grant Miller, who's our project manager for Zooniverse. He and I compete for this lovely trophy, this is a small, very cheap trophy. This is the Astrophysics Real Tennis World Championship. So any astronomer who plays real tennis can challenge for this trophy. There are only 2 of us so far. So that exists. And the rest of people I've met and played through tennis and become great friends with.
So what other sports are you into?
For playing it, tennis is my thing. I am an enormous football fan. it's my link back to where I live is that I'm a Torquay United fan. So I grew up in South Devon, and I still follow the team. And then I've picked up other teams. So I lived in Chicago for a while. I got very interested in the Chicago Fire, who are a Major League Soccer team. And what actually the culture in Chicago was amazing, because these fans had sort of had to create a culture of what it means to be a football or soccer fan in the States, and they sort of nicked bits. So they tailgate, which is what you do before normally an American football game. So people turn up and stand in the car park with their friends for 3 hours before the match. There were tailgates where we didn't bother to go in because the team were terrible and we were having fun outside. But then they had sort of, there's a Mexican tradition of having a band in the stands. So you find yourself on a football terrace with people playing the trumpet next to you, and so on. And then there is the English thing of chanting and screaming and so on, but also bits of Italian and Polish influence. And it was really good fun to be part of that and scream and sing and shout at a team that have been useless since I started supporting them 10 years ago. They were apparently really good before I got involved, but unfortunately, I seem to pick only losing teams.
You started with Torquay, which I'll be careful.
Well, we had a good season this season. The playoffs, by the time this comes out, we may have been promoted. So maybe you want to edit in me saying that it's been a great season and Torquay are brilliant. But I'm afraid it teaches pessimism being a Torquay fan. I mean, this is a team, my dad remembers being there. They hold the record for the fastest own goal in professional football. So they scored an own goal 12 seconds after kickoff. And I think that more or less sums up Torquay. My first match, I imagine the crossover audience with Torquay United fans are low, but my first match involved the club being saved from certain doom by a police dog running on the pitch and biting one of our players. This is the kind of thing that happens to this ridiculous team, and it's been great to follow along over the years.
Because this picture hasn't turned out. I didn't check the orientation of the picture first, so it's my mistake.
Yeah, I enjoyed this. This was me getting my vaccine. So this is a picture of me at the Kassam Stadium, which is Oxford United's home ground. And there was a past where Oxford and Torquay were in the same league. So I wore my Torquay kit to get my vaccine. I was desperately hoping that some Oxford fans would notice, but no one said anything. But I thought that was quite a nice link it sort of brought my worlds together, because I had the vaccine that was developed here in Oxford at the stadium in my football kit, and that was all very nice. I tweeted this picture and got thanks and thanked the team who developed it, and I saw that several of them had seen it. I keep thinking about that fact that a year and a half ago they were in a lab trying to work out what on earth to do, and now here we are with people being vaccinated by something that was developed by a bunch of scientists up the road. It must be an amazing feeling.
Just again, back to life science.
Right. Yeah. I didn't say your problems were unimportant. I just said they were difficult.
Yeah, and the responsibility that team had. What a profound impact.
Yeah. Well, let's hope so. I'm sort of sitting here waiting to see what the summer's going to be like. But let's hope this is the beginning of being able to travel again.
Worry too much about that and see how it goes. Throughout your career, what's been the most challenging time? You're only 40. If you're insanely young, what have you found the most challenging time in your career?
Oh, there've been a few. I think the hardest problem, which we keep coming up against in waves, is to keep stuff going. There's always an appetite for new ideas, and we have plenty of them, and that's fun. But we've accidentally built a platform that hundreds of research teams use for their own research, and everything from life sciences to ecology to my own astronomy. And it's very hard to write a grant proposal that says this is good, we want to do more of it. And so the thing that keeps me up at night is working out how to keep that platform going. And one answer is that we can keep being different. So the new ideas help. And the platform has changed immensely over the 14 years. We're not trying to do now what we were doing in 2007 or 2010 or even 2017. But I do feel there's this responsibility to keep the thing going and to keep the team together. So I should have said that the Zooniverse is not my production at all. I mentioned Helen, but the other scientist, Grant. But there's a web development team split between my team here in Oxford and the Adler Planetarium in Chicago, and that's really tough, I think. On a personal note, I think the hardest time was just after my PhD. I deliberately come to Oxford to learn stuff. I wanted to move away from some of the astrochemistry I've been doing and get involved in new problems. And for the first 6 months I was here, I was pretty sunk. I didn't really know what I was doing. I didn't have the knowledge to attack the problems that I was supposed to be working on. I had a boss who was very friendly, but at 3 p.m. every day would knock on the door, come into the office and have an idea at me. And so I had a steadily growing list of ideas that I thought I was supposed to be working on. It took me a while to realize he did this to everyone, and that was his way of thinking, and the requirement was to have a conversation. But I felt really, really sunk, actually. And I got 9 months into a 2-year postdoc and was pretty sure that would be that, and then thought, well, I've got to do something. I don't care what it is. So I set up this nice side project called Galaxy Zoo, because I could at least spend a couple of weeks building a nice website and getting people to classify galaxies. And at some point, I should go back and do the work I was supposed to be employed on for that postdoc, because I haven't really recovered from that. But yeah, I think anyone who tells you that they can be a researcher or have science as part of their lives and not have times where they don't know what they're doing, well, I'd like to meet them, because that sounds rather wonderful. And I've never met anyone who's ever gone through a career without getting really stuck. And that was mine.
Which is good to hear. I think, you know, it's good for people to realize that it doesn't go to plan quite often.
And sometimes I think the thing I took from it was that sometimes the requirement is to do something and not to worry too much about making a choice or thinking about what would be best to do, but do some research, find something out, read something, think about something, and you know, I occasionally talk to early career scientists who are trying to worry about, if I write this paper now, then I can get this fellowship, and then I'll do this, and then by the time I get to a faculty job, I'll be able to do. And it's good to think about those things, but in my experience, at least, the path is much more random, and you're going to be much more buffeted by random events, jobs that open up, data that becomes available, things you find. And so it's almost not worth worrying about too many steps ahead. And really it's about like what one can get done with what you've got in front of you. The only time in this whole interview I've actually felt old is when I'm giving advice. Like the only time I thought about my age is I sound somewhere between, in my head, I'm sort of a 20-year-old going, yes, well, let me tell you kids what it's like to be as old as 20. And yeah, I think I also coming across something like an 80-year-old crusty professor going, well, in my day, I just worked at it and it all ended up all right. So being involved in science where we don't know the answers is really tough. It's really hard. And I think it's okay to say that sometimes.
It's certainly not a stress-free environment. That's for sure. So our time has flown, and I've still got a few more. I've got some quick-fire questions.
Okay, let's try and do them as quick-fire, shall we? We can do this.
Okay. What's your favourite item that you own?
I'm not really a person who cares about things really. I will go for this crochet. This is a crochet lobster, which has a backstory that I'm not going to tell you, but this lobster is excellent.
Okay. What's your pet hate? Habits or otherwise?
Gosh, these are difficult. Why are these difficult? I guess I should need. Celebrities seem to have these pat. I need a list.
Well, you present the Sky at Night. You should have these. Come on.
No, pet hate. People who assume that they're being boring. I hate you won't be interested in this. Like, everyone can be interested in everything. We should start from the assumption that everyone is interested.
You said you might not be very interesting in this.
Yeah, well, I do it myself. I'm not just saying it's. I'm not saying it's not a habit I've developed. But I think it's a natural thing, isn't it? It's like to assume that you're boring people. But my experience, my long experience, people tell you if you're boring them. So I think we should all be just assume that our audience is interested.
Okay.
I think it goes back to the science communication stuff. I think too often we're filtering, you know, what we're saying to an audience because we're trying to guess what they're interested in. Actually, people are interested in people, and you know, if you're being excited about your science, I want to hear about it, even if I don't follow the details, and even if I've never thought about cell biology or whatever or protein structure before.
I'll make these even quicker answers then. Night owl or early bird?
Both, but not the afternoon.
Okay, fair enough. What's your favourite food?
Szechuan.
What do you hate food-wise?
Weirdly, milk in coffee.
Milk in coffee?
Yeah, I drink black coffee, but any coffee flavored things or anything that's messed with. So yeah.
Favorite drink?
I'm dreaming of a decent pint of bitter in a pub because there haven't been enough of those. So let's go with that.
Okay. Favorite movie?
Contact.
What movie genre do you hate?
Horror. Scary.
Okay. Fact or fiction reading?
Fact in the morning, fiction's in the evening.
Trashiest TV program that you secretly like?
I'm not a huge TV person. I watched all of Grey's Anatomy for some reason.
Okay. Favorite item of clothing?
I've got one really good shirt that I'm not allowed to wear on camera because it's too patterned. It's like a swirly paisley thing.
Oh, that takes me back. Anyway, I'm digressing now. Okay. Music genre. What's your favorite music genre?
Depends on the day of the week and the weather, but the blues.
Okay. And you sent me finally some pictures, which
look
rather psychedelic with keyboards and
yeah. Mixers. So this is the home office of my friend Steve Pretty. So Steve is an amazing jazz musician. He's the leader of a band called the Hackney Colliery Band, which you should go and listen to. They are brilliant. If you want to hear a modern jazz medley of Nirvana's greatest hits, for example, they're your people. But they also do other things. But Steve and I met doing various things, and we've been collaborating on shows where I explain astronomy to a jazz audience and he explains jazz to an astronomy audience, possibly satisfying nobody. But they're good. I have a very, in the early days when the show's now pretty good, but when we started, the show starts with Steve walking into the theatre, blowing on a conch, and through the audience. And then I come in and read some of Stapledon, actually, the Olaf Stapledon piece that I was talking about earlier. But yeah, the first time we did that, Steve walked in, blew his conch, and this amateur astronomer who'd come to hear about astronomy went, "Oh no!" right over the top of it, which is great. Anyway, the thing I sent you, I hope you can put a link somewhere, is that we discovered a system of planets which are in resonance. So K2138 is the system. It has 5 planets. The innermost one, for every 3 times that goes around, the next one goes around twice. For every 3 times that goes around the star, the next one goes around twice, and so on. And so you can sonify this. Steve took the sonification and produced this slightly psychedelic, but mostly mellow, beautiful, improvised jazz piece playing with the solar system, which I just think is wonderful. And it's a really nice example of where astronomy can take you. The great joy I have is working with everyone from your friends at the Crick to people like Steve to try and find out about the universe and talk about it.
I'm going to have to ask Bitesize Bio if they can actually put just a little end credits, the song in the background, or maybe
go for it.
StevePretty.com. So the website is there for it. I think it's www.stevepretty.com.
StevePretty.com. Yeah, exactly. He's also the house band. He's running the house band at the Globe's production of Midsummer Night's Dream this summer. If you want to go and see some theatre and feel safe going to an outside place,
so you can actually listen to your music, literally the sound of space. It's cool. Chris, you've been great to talk to today. Thank you very much. Yeah, I said it'd be about an hour. I think we've gone a bit over, but you know what? This has been terrific. Far from boring. Which
well, I hope so. It feels incredibly self-indulgent to sit and talk about yourself for an hour. So thank you for that. That's been fun.
Think about how many people, not many people can say they've inspired 2.3 million armchair scientists, and not just armchair scientists, serious scientists from 5 to 95 to get involved to help, from astrophysicists to biologists to ecologists, right across the board. Fundamentally inspiring, absolutely brilliant. So anyway, Chris, thank you very much for today and taking the time to join me. And everyone else who's listened, please do watch some of the other podcasts on the Microscopists. And yeah, do you know what? This has been brilliant. Chris, thank you very much.
My pleasure. Talk to you soon.
Thank you for listening to the Microscopists, a bite-sized bio podcast sponsored by Zeiss Microscopy. To view all audio and video recordings from this series, please visit bitesizebio.com/the-microscopists.